All right, guys, here we go. Pre-calculus, chapter 12, section 1 is this is going to be your introduction to limits. This is also going to be our last chapter of the year. It's also going to give us once we get into introduction to limits, and then it's going to progress over to derivatives, which is all about calculus. Calculus is all about derivatives. Okay, so this is getting us into the next class of calculus. All right, so introduction to limits. We want to determine if limits exist and evaluate limits. Okay, if f of x comes close to L limit as x approaches c from either side, then the limit of x approaches c of f of x is L, the limit. Okay, so ideally you want to plug c into your function, and limit is the number L when the left and the right side are equal. Okay, so some basic ideas behind limits. The limit as x approaches a constant c of just a number b is going to be b. So limit of x approaches c of b is going to be b because there's no x in here. So a constant, then it doesn't matter what x is. This number b is going to be the limit b. Now limit of x approaches c of x is going to be c, because x approaches c, this guy is going to be c. X approaches c of x to the n is c to the n. And limits, if you add the functions and then take the limit, is the same thing as taking the limit of each individually and then add them. Limit of f times g is the same thing as limit of the each one of them separately and then multiplied. So it doesn't matter if you multiply the functions first and then take the limit, or take the limit of each function and then multiply the result. Okay, so we'll do some examples of some limits. Okay, so let's go through some. All right, so my first example, limits, idea behind limits is very easy, but it gets us into calculus material. Okay, let's say, for example, limit as x approaches 3 of 5x minus 2. All right, so if you just simply plug it in, okay, if you have no trouble with doing that, then that's it. 5 times 3 minus 2, 13 is your answer. 13 is your limit. That's it. So normally, when you want to do a limit, just plug it in. If it comes out to be a regular number, then you're good. All right. Only time you worry is when it's undefined. Okay. So be aware of that. If you can take the number and plug it in and it works out, then that's perfect. Sometimes though it doesn't work, and so that's when you have to kind of worry. Okay. So for example, this guy is one you have to kind of worry a little bit. Okay, x approaches 0 of x over square root x plus 9 minus 3. Okay, so this is one you might have to worry. So if I was to plug in 0, it'll be 0 over square root 0 plus 9 minus 3. That's going to be 0 over 3 minus 3. 0 over 0. Ooh, we don't like this at all. So this one, okay, doesn't give us information. So we have to rationalize this, okay? So when it gives us this right here, when we take a limit and you get a 0 on the denominator, that's no good, okay? Especially when you have 0 on top and bottom. So when you run into that, you have to be careful, okay? So we now have to figure out what to do with this, okay? So we have to rationalize this and see what happens. Limit as x approaches 0. Now remember, rationalizing, you multiply top and bottom by the conjugate. X plus 9 minus 3. So we're going to multiply top and bottom by the conjugate of this, which is square root of x plus 9 plus 3. Multiply that. Same thing to the top. square root of x plus 9 plus 3. Remember, this is called the conjugate. Conjugate. So we're going to multiply to the top and bottom. So we get x multiplied with square root x plus 9 plus 3. And then on the bottom, we're going to get here, if you remember that we're supposed to FOIL. Okay. When we FOIL, we get x plus 9, right? Square root times square root is just x plus 9. And then these are dots, so minus 9. So when you simplify this, you get x over x, and then x plus 9 plus 3, right? So by rationalizing, you get the x's go away. And so this is going to be square root x plus 9 plus 3. Now we want to take the limit as x approaches 0. You see that? Earlier when we put in 0, we were in trouble. We got 0 over 0. We don't even know what that means. So now that we've simplified this problem using the conjugate, well, this shouldn't go away. We want to take the limit of this. Now we plug in 0. Then we get square root 0 plus 9 plus 3, which is 6. Okay, so this limit earlier we had 0 over 0, which was no good. We don't want that. But after we simplify, we got 6. So that's how we do that. Okay, so anytime you get a 0 on the denominator, you have to try to figure out what you can do to simplify the problem. So for example, x cubed minus 2x squared plus 2x minus 4 over x minus 2. Okay, again, I plug in 2, I'm going to get 0 on the bottom, right? If I plug in 2, 0 on the bottom. So right then, I know something is wrong. If I plug in 2 on top, I also get 0. So that's no good. We don't want that. So what we can do is factor this out by grouping, right? X squared, the first two have x squared in common. You get x minus 2. The last two have a negative 2 in common. Well, actually 2 in common, x minus 2 again. Okay, x minus 2 on the bottom. So x squared plus 2, x minus 2, and on the bottom x minus 2 again. See how when we think about the problem, 0, 0 is no good. So that means we have to do something. So in this case, this will cancel out. Okay, so we end up with limit as x approaches 2 of x squared plus 2. You see? And when we get a 0 on the bottom, we know we have to simplify the problem. Okay, now we try to plug it in. 2 squared plus 2, 6 again. Okay, so anytime you have a 0 on the denominator, that's when it's kind of, uh-oh, I have to figure out what to do with it. Okay. All right. Couple more examples. So an easy one again. Let's say, for example, limit x approaches, let's say 2 again of x cubed. Again, simple. Just plug it in. 2 cubed limits 8. So they see that that's not a problem. Another one that will be pretty simple. For example, x equals 2 of x squared plus 5x plus 4. We plug in 2 in here, and it doesn't give us a problem at all. 4, 10, 4, so we get 18. Okay, so pretty simple idea behind limits. Just plug it in when you can. Now again, you gotta remember, there are some times when you have a problem, like this guy. Okay, now we can't simplify this, but what happens when x approaches 0? Okay, so think about it in two scenarios. This one, you can't simplify it, but if you think about this problem, limit as x approaches 0 on the positive case, on the positive side. Okay, So imagine the number line. Here's 0. Okay, here's you. What happens when you are walking towards 0 from the positive side? Okay, from the positive side, you're going to get a positive number and a positive number. So you're going to get 1. Okay, well, what happens when you approach 0 from the negative side? Again, here's 0, here's the negative side, here's you. What happens as you're walking towards this way? When you're on the left hand side, on top, you're going to get a negative number. But on the bottom, because absolute value, you get a positive. And so -1 now. So you see, on the right hand side, you're going to get +1. On the left hand side, you're going to get a -1. So this answer is no limit. This one's a unique problem where there's no limit. Okay, so be aware of that a little bit. Last example, well, maybe 2 then. Okay, limit x squared minus x minus 20 over x plus or minus 5, and x approaches 5. Okay, again, we plug it in, we get 0 over 0. That's not good. Okay, we don't want that. So that means we got to examine this a little bit, and we notice it's factorable. X minus 5, x plus 4, on the bottom x minus 5. So now we notice that these two cancel. So limit as x approaches 5, after we cancel, this problem just simply becomes x plus 4. So now we can plug it in, 9, easy. Last example, okay? Limit as x approaches 4, x minus 4, square root x minus 2. Okay, so what happens when we plug in 4 here? We get 0 over 0. Okay, again, 0, 0 is scary. We can't have that. So we had to figure out what to do here. But here, if you remember, we did this beginning of the year. X minus 4, in a way, if you think about it, is dots, right? If you remember, we talked about this being dots, minus with these two numbers being square. So what times itself gives us x? Square root of x, square root of x. What times itself or gives us a 4, but here -4. So -2 and +2, right? That's called dots. And x minus 2, square root x minus 2, limit as x approaches 4. Okay, so again, what we notice is these two cancel. Limit now of x approaches 4 of square root of x plus 2. Now we can plug in 4 and we get 4. There you go. And that's your limit. Okay, so try some of these problems on page 822. All right, have fun.